Assalamu alaikum, my dear brothers and sisters. Welcome back in action. This is your brother Abdi Muhammad for your information. Guys, in high school, we're going to discuss about vector 2, which is the vector of form 3, and basically the one that 98% comes in every case is, okay? The fact on ground is that vector is very easy, as we all know, and I'll be teaching you this concept of mathematics in a chronological manner so that you don't get lost in the process of capturing or grabbing the information based on vector of form 3. And remember we said that a vector of form 3 will carry 4 marks and 10 marks in the examination, okay? And most probably the one with 10 marks will come from form 3 vector for your information, guys. Without wasting time, we're going to discuss under this chapter, we're going to discuss about column vectors in terms of unity vector I, J, and K. Before we proceed ahead and see the concept with examples, I would like to give you some tricky so that you can use during examination. When we're saying IJK, vector IJK, we are talking about three-dimensional vector for your information. Just understand that. We are talking about what? Three-dimensional vector. Then when you're talking about I, make sure you grab this information, okay? When you're talking about I take this format. I take this format, yeah, in scalar form, in column vector, I takes this format, 1, 0, 0. This is for I. Then J will take, J is the middle one, because for us to write the three of them in column vector first, we are going to write them like this, don't forget. So now, when you want to talk about I, the I will be 1. J and K, you will replace them with what? With 0. So I will take this form, yeah? 1, 0, 0. Then for J, it will be, this time I and K will be zeros, okay? 0, 1, okay? 0. So J will have a value of 1. Just understand that. Then when you're talking about K, K will have a value of 1, but the other two will have a value of 0. So in this situation, you're going to say 0, 0, 1. Make sure you understand this thing first. So this is for I is 1, 0, 0. J is 0, 1, 0, and K is 0, 0, 1. Okay, let's start from the fundamental concept here. Just understand that. Okay, having this one in brain, we are going to calculate column vectors in terms of IJK, okay? Column vectors in terms of the unity vector IJK, guys, for your information. Okay, make sure you have this one in brain here. I is 1, 0, 0, J 0, 1, 0, and K 0, 0, 1. I think there's nothing hard here. Okay, having that one in brain, let's see examples. Okay, let's see examples. And make sure you have your calculator and whatsoever, okay? Your pens, calculator, your calculation book, go with me then. I'm sure at the end of this, you'll enjoy a lot, okay? Let's now see, without wasting time, the first example. We have example 1. You're told, express vector 5, negative 2, 7 in column, okay? In terms of the unit vectors, I, comma, J, and K, okay, and K. For you to express this vector in terms of IJK, this is what you're gonna do, guys, for your information. Okay, this is what you're gonna do. So we will have for I now, we know that as far as the unit vector of this concept is concerned, the unit vector of IJK is concerned, this is what we're gonna do, guys. For I now, this is I, we know that I is 1, 0, okay, 0. This is for I, for your information, guys. This is for what? This is for I, for your information. Then, comma, for J, it will be like this, for your information. J will be 0, 1, 0. This is for J. Let me write that. let me write that. Okay, let me write that. This is j. J is what? J is the middle one, so the middle one will have one value, 0 1 0, comma, then your k is what? K is k will be actually, k is the last one, it will be 0 0 1, having this one in brain. Okay, but the I value here is 5. Okay, the I value is what? Is 5 for your information. So I can be written as I is equal to 5 into 1 0 0. Factor out this one, yeah? Just understand that. Okay, the I value in this situation is 5, and this is the tree diagram vector that represent I as far as the unit vector is concerned. Okay, then we can also say plus. For j now we have -2, and j is this one, so we can say, look here, we can say 5, sorry not 5, -2 into, we are dealing with the j, yeah? 0 1 0, plus, then we will have this one as 7 into what? Into k, which is k value is what? 0 0 1. Just understand that, yeah? This is how it takes. Okay, then we are going to say this is the case, this is for I, don't forget. So we say 5 into I, because we know that I is represented by this one, which is now I, plus -2 into j, because this is for j, close the bracket, plus 7 into k. So this will give me 5i minus, because you have positive and negative, minus 2j plus 7k. This is actually how you are going to work out to get the final answer for your information, guys. Make sure you catch up with us from the base, okay? From the base of vector function. I'm sure at the end of this class you will not suffer. Just understand, take your time, yeah? Take your time, understand. When you're talking about three-dimensional vector, particularly the one of form tree, okay? In terms of I, j, and k, remember we have a concept, a hidden knowledge here, which is for I, if you want to write I in terms of the three-dimensional vector, I will be represented by 1 0 0, j is 0 1 0. Remember the order is this one. I, this is the order. I, j, k. When you're talking about I will have one value. Then the other two will have 0. Just understand that. So it's a matter of substituting those ones inside the bracket, okay? Placing those ones inside the bracket. So for I, it will be 1 0 0. For j, it will be 0 1 0. For k, it will be 0 0 1. Then this is for I. If you multiply this one as a scalar for the unit vector of I, which is 1 0 0, then you will have this one. So having in brain that 1 0 0 is for I, then you can say 5 times I plus -2 into j. This is for j. Wherever you see 0 1 0, that's for j. Then wherever you see 0 0 followed by 1, and that's for k, then you multiply by 7. Okay, this is how you're gonna solve or express a given vector in column form using the unity vector, which is I, j, k, guys. Very good, okay? I hope you have digested that one. Now we will also see, let me write here, because this reflection of light I can understand. Okay, let me write down here. That's how you're gonna express the vector, any vector in terms of column into a form of I, j, k. Let's go ahead and see example 2 here. This will be our example 2, guys. Let's see this one. You are told if A is equal to 2i, if A is equal to 2i, okay, 2i plus j plus 5k, okay, and B is equal to 3i minus, not plus here, sorry, minus 4j plus 7k, okay, 7k. Then you're told, comma, find question A, we have A plus B. Then question B, we have 3A plus 2B. Let's see whether mathematics is hard or easy, okay? I think this is very, very easy for your information, guys. This concept is very easy. You are told, let's look for the solution. We have A plus B. Let me write A in terms of column vector, yeah? So it will be 2i, j alone, okay, 5k inside the bracket plus, okay, because we are saying A plus B, and we know that A is equal to what? This one, and B is equal to this one, okay, plus, because we have addition here, it will be 3i minus 4j, then 7k, okay. So what are we going to do? We are going to say, open another bracket, that is 2i plus 3i, then down there we'll have j minus 4j, because j plus and minus to be minus, just understand that. Then down there we'll have 5k plus 7k, close the bracket. 2i plus 3i, this will give me what? This will give me 5i, okay, 5i, here we'll have negative 3j, negative 3j, negative, yeah, just understand, negative 3j, then we'll have 12k, okay. You can leave your answer in column, or you can leave your answer in just like horizontal manner. You can say 5i plus, not plus, minus 3j plus 12k, okay. This is how you're going to solve, guys. Just understand, it is very, very easy. I don't know why people are saying vector form to this hard. It's not hard. Who say that mathematical value or high school is hard? It's not hard. Vector is the easiest part, and I'm sure in KCSE it will carry 10 marks, okay. I'll be solving for you questions based on diagram that will carry 10 marks in KCSE, okay, so that you are well familiar with the concept of vector during national exam. Let's now proceed and see this one. 3a plus 2b. This is question B. Here we have 3a plus 2b. 3a means 3 times a, and a you have. So you can say this can be written as 3, then a written in column. That is 2i. Let me write well. 2i j 5k. Okay? 3a plus 2, open the bracket, b. Our b is what? 3i minus 4j. This is minus 4j. Minus 4j. Then down here we have 7k. So this can be written as, look here, 3 times 2i, that is 6i. 6i, yeah, just understand, this is 6i. 6i, this time is this 3j. This time is this 15k. Close the bracket. Plus, open the bracket again. 2 times 3i, again that is 6i. This time is this, it will be minus 8j. Then this time is this is 14k. Just understand that. 14k, yeah? 14k. And this is negative 8j. Minus 8j. So from here we can say 6i plus another 6i. 6i plus 6i. Down here we'll have 3j minus 8j. Because we have plus and minus, it will be minus, yeah? Just understand that. Then we will have 15k plus 14k. So this will give us finally 12i, okay, minus 5j. This is 12. Here we'll have 29k. This is in column. Or you can write 12i minus 5j plus 29k as the final answer for your information, guys. That will be the final answer and how you're going to solve during a normal exam or cases, you guys. Now, this is how you're going to solve questions based on IJK for your information when it comes to addition and of course subtraction if you're willing to do so. Okay. Now let's see magnitude of vectors of two-dimensional vector. The magnitude of two-dimensional vector is what we're going to see after this, guys. Okay. Let me wrap this part. I hope you're with me. Okay. Let's see this one. Let's see this one. I hope you're enjoying and you have your pen and your book, jotting down or calculating, of course. You must write the concept here on the whiteboard. Write after me, go with me, then I'm sure you'll enjoy a lot. Let's go, guys. Who said mathematics of high school is that? Vector is now in hand. So we have to digest the concept of vector, okay, so that we don't suffer or panic during our national exam. Okay? Now, the next concept we're going to discuss about this vector of quantity is that we have the magnitude. Magnitude of a vector in 3 dimensions, okay? This is what we're going to discuss. Remember, we have discussed about magnitude of vector of form 2, where we say that the magnitude of any vector A, like this one, is equal to the root of x squared plus y squared. And magnitude is written like this. The magnitude of A is written like this, okay? Just understand that. This was form 2 concept, by the way, and it was very easy. Okay? We are done with that. Make sure you go back to our YouTube channel and do the right thing, okay? So, but this one, we are dealing with what? We are dealing with 3 dimensions, okay? That is the IJK for your information. The IJK concept of vector form 2, okay? Sometimes you'll be told like this. Find the modulus. Find the modulus. The modulus means what? Magnitude of the following vectors. Of each of the following vectors, okay? Okay. Then we have the first one as 2, 4. Look here, bear witness here, please. 2, 4, 7. Okay? 2, 4, 7, okay? Remember, we are talking about the IJK vector for your information. The IJK vector. I can still give you a new formula so you don't suffer for your information. This is the I, this is the J, and this is the K. So as far as my knowledge of mathematics is concerned, let's assume now this is a vector of tree diagram of form 3 IJK. Now let's say this is vector A. We can say for us to get the magnitude of A of this vector, which is 2-dimensional vector, we can say the IJK arm, you can say x, y, z, where this one you consider as x, this one is x, y, z. Okay, you can say that. Let me introduce this formula to you, which is very rare in high school, of course, and it will help you during national exam. So you can say x squared plus y squared plus z squared, where this is x, this is y, and this is z. Okay, remember this is z. Okay, then from here the magnitude of this vector is equal to the root of 2 squared plus 4 squared, yeah, just understand that, plus 7 squared. So let me get this one. The magnitude of this vector A is equal to the root of 4 plus 16 plus 49. Okay, 4 plus 16 plus 49, that's 69, yeah. So it will be the root of 69, which is equal to, get the root of 69, yeah, that is the root of 69 is root 69 is 8.31. 8.31 units. Just understand that. 8.31 units. Okay? You can say that. It is very easy, by the way. Can't you see how we calculate the magnitude of three-dimensional vector? Now let me add for you one more. Let me add for you this one. B, let me add for you this one so that you enjoy during national exam. We have -5, -12, and 0. Let's call, let's say the magnitude of this vector is equal to, writing times of x, y, z, x squared plus y squared plus z squared. Now the magnitude of this vector will be now -5 squared plus -12 squared plus 0 squared. In this situation, we'll have the magnitude of A is equal to, this will be 25 plus 144. Okay, 0 squared is 0, forget. Okay, then the magnitude of A therefore is equal to the root of 169, which is equal to 13 units. Okay, 13 units. Final answer. Okay, that is the final answer for your information, guys. So this is how you're going to calculate the magnitude of a vector. Okay, okay, for your information, that's how you're gonna calculate the magnitude of a vector. We'll go ahead and see another concept, which is parallel vectors and collinearity. Of course, that's what you're gonna see as we go ahead. Okay, I hope you can get the magnitude of three-dimensional vectors from today. Make sure you go through this and do research. Of course, you also do research for your information, guys. I hope you have digested and you have written. If I'm not wrong, make sure you do research, okay, based on this fact of mathematics. Okay, now let's go and see parallelity of a vector. How are we going to test whether two or more vectors are parallel? Okay, how are we going to test that? Okay, whether two or more vectors are parallel. Okay, let's see that. Let's see that. Okay, let's see this one. This is what we're gonna talk. Parallel vectors and collinearity. Collinearity from the word collinear. Okay, the reason as to why they're using the conjunction and here is because parallel vectors and collinear vectors have got some relationship. Unless or otherwise you know how to test the parallelity of a vector, then you cannot test the collinearity of a vector. How you cannot test whether two or more vectors are collinear if you cannot test whether two or more vectors are parallel. Okay, just understand that point, please. So that's why we're using the conjunction and here. So these two goes together. Yeah, just understand. The moment you test parallelity, you know how to test parallelity of vectors, then you can test also collinearity. Okay, because for us to test the collinearity of two or more vectors, or to test whether two or more vectors are collinear, then we must know how to test parallelity of those vectors for your information. Okay, without wasting time, I'll teach you how to test whether two or more vectors are parallel, okay, or not. Okay, now let's talk about parallel vectors. And this, we will discuss this one first so that you understand. Yeah. Okay, now let's see the first example. Let's see the first example. We have which one of the following we are told. Which of the following pairs of vectors are parallel? Which of the following vectors are parallel? Okay, so we need to see whether these vectors are parallel or not. Okay, we have A is equal to, in column here, 4, -3. This is A. Then we have also B is equal to -12, 9. So we need to test we need to test whether these two vectors are parallel or not. Very easy, by the way. So how are you going to test? Okay? How are you going to test that vector A is parallel to vector B? This is the case. We are going to say, you can say like this. Okay, mathematicians, because cannot rely on one way, okay? You have to go for different ways to arrive at the same answer. But the simplest way is, let's say like this. Ka is equal to B. Ka is equal to B, where K is a scalar. Where K is a scalar. Okay? Which means if a certain scalar is multiplied by this one, we'll give you this one, then those two vectors are what? Are parallel. Or if the scalar times this is equated to this one, and again if you multiply the scalar by this one, then you equate to this one and get the same value with the same sign. Just understand that? I'm saying if you take a scalar, let's say the scalar is what? Is K. K multiplied by 4 equated to negative 12. If K multiplied by 4 equated to negative 12 gives you the same answer as K multiplied by negative 3 equated to 9, then the two vectors are parallel. Okay? Just understand that. If K is multiplied by this 4 and equated to negative 12, is going to give you, when K is multiplied by 4 equated to negative 12, will give you the same results as multiplying K and equating to 9 with this, will give you the same result with the same sign. Just understand that? With the same sign. Then the two vectors are parallel. Just understand that? If K multiplied by 4 equated to negative 12 will give you the same result with the same sign, K multiplied by negative 3 equated to 9, then the two vectors are what? Are parallel. They are parallel, of course. They are parallel, by the way. Just understand that. So now let me prove it right. Let me say K into 4 negative 3. This is 4, remember, don't forget. This is 4. Is equal to negative 12, 9. So one time I'll say K times 4. 4K is equal to negative 12. Then to get the value of K, divide both sides. So K is equal to negative 3. We are testing parallelity. Just understand that. Again, K also. K multiplied by 3. That is negative 3K. K, what is it? K multiplied by negative 3 is negative 3K. Is equal to 9. Then divide both sides by negative 3. Cancel. So K is equal to negative 3. So you are getting the same answer. Okay? So we can say, hence, A is parallel. This is the parallel sign. A is parallel to B. Just understand that. A is parallel to B. Just understand that. Are you capturing this thing, please? Just if you're getting the same value with the same sign, then the two vectors are parallel. But if you're getting the same number, but of different sign even, the two vectors are not what? Are not parallel for your information, okay? So we are saying two vectors are parallel if vector A is a scalar multiple of vector B, okay? Just understand that, okay? If a certain scalar multiplied by vector A will give you vector B, then the two vectors are what? Are parallel for your information, guys, okay? Don't forget that. The last but not the least for today's class is a test of collinearity, collinear vectors. Collinear vectors, okay? Or test of collinearity. Let me say that. That's the best way, okay? Test of collinearity. I want to test collinearity. For me to test collinearity, as I told you initially, I must know how to test the parallelity of a vector. Okay? Now let's see how to test collinearity of a vector. Okay? Now let's see. For two or more vectors to be collinear, we said what? We said what? The test of collinearity of 3 points involves showing that the vectors between any two of them are parallel. The vectors between any two of them are what? Are parallel, yeah? Just understand that. So you must test parallelity first. Then you're told vectors in Roma 1 or the first vector has then the vectors have a common point. They must have also what? A common point. Just understand that. Now let's see this one. Let's test what? Collinearity. Because we have 3 points, okay? You are told A 0, 3. A is 0, 3. Then we have B 1, 5. Then and you are told C is what? 4, 11. Are 3 points. Are what? 3 points, okay? Show that they are collinear. Show that they are collinear. Okay? They are collinear. So we can say, we test for parallelity, and we say that for parallelity now, coming to the solution, yeah? Let me start with this place, yeah? We can say KAB, when there are 3 in number, don't forget. K times AB must give us what? BC. If a certain scalar multiplied by the difference between A and B is equal to the difference between C and B, then those two vectors are what? Are parallel, because we were testing only parallelity of 2 points. But for you to test the parallelity of 3 points, yeah, this is the case. Yes, understand? So let me get BC, B minus C. First I will get what? B minus C, to make for you the work easy. You can say 5, 1, 5, B is what? 5, minus 0, 3. So this will give me, open a bracket, 1 minus 0. 1 minus 0, 5 minus 3. This will finally give us 1, 2. If we have 3 points and we want to test for parallelity, and the points are A, B, C, get the difference between B and A, and also get the difference between C and B. Now, if the difference between B and A multiplied by a certain scalar, just understand that, yeah? If the difference between B and A multiplied by a certain scalar will give you the difference between C and B, then the 3 vectors are what? Are parallel, my friends. Let's go. So let me also get the difference between what? C and B. So let me also say C minus B, because there are 3 this time, 3 points. Just understand. Okay, that will give me 4, 11 in column minus 1, 5. So this will give me what? 3, 6. Yeah, it is 4 minus 1, 11 minus 5. So let me say like this. K into the product, the final answer here. 1, 2 is equal to 3, 6. We say what? If the difference between B and C multiplied by a certain scalar, just understand that. The scalar can be K or C or M, whatsoever it is. Yeah? But we said constant and scalar will take C and K. Okay? Yeah, of course. So we can say K times 1 is K is equal to 3 one time. K times 1 is equal to 3. So K is equal to 3. You can also say K times 2. That's 2K is equal to 6. Then divide both sides by 2. Cancel. K is equal to 3 also. So you can see now the 3 points are what? Are parallel. The 3 points are what? Are parallel, of course. Just understand that the 3 points are parallel. Because you have tested parallelity, because you are getting the same scalar. Okay? That was testing whether 2 points are parallel or not. Here we are testing 3 points. And we want to test the 3 points. Get the difference between the second and the first, and also the difference between the third and the second. Then if the difference between the second and the first multiplied by a certain scalar will give you the difference between the third and the second, then the three vectors are what? Are parallel, my friends. Very easy. Okay? Now, can't you see now, for us to test collinearity or whether 3 points are collinear again, we must test first what? Parallelity. Whether the 3 points are parallel. Okay? We have tested and confirmed that the 3 points are what? Are parallel this time. Okay? But now, how can we inform them that the 3 points are collinear or they are on the same line? Okay? We can say here, we can say AB is parallel to BC, and look here, and 3AB is equal to 3 times AB, the difference between A and B, is equal to BC, and B is a common point. Is a common point. Hence, the 3 points. Hence, the 3 points are collinear. Hence, the 3 points are collinear. Look at this statement. AB is parallel to BC, and 3AB is equal to what? BC, and B is a common point. Hence, the 3 points are what? Are collinear. You have tested collinearity. Very easy. Okay? Right. The common point here in this situation is B. I hope you have digested this concept of the fundamental concept of form 3 vector. I'm sure in our next class, my goodness. Guys, make sure you must read this class, yeah? Make sure you go and do research about this knowledge of vector. Make sure you subscribe this YouTube channel and share with your family members and friends as well. People who are stranded by this pandemic. This is called the pandemic. This is called COVID-19. Okay. I'm sure in our next class we're going to discuss about questions of 10 marks based on diagram. Make sure you bear witness with me. Okay. In our next class, God willing, I'm sure we'll enjoy a lot because I'll come up with questions of 10 marks, and from that point, then you will not have problem with vectors or form 2. Okay. My prayers are with you guys in form 4 currently. I know you'll be doing an exam on March of next year, and hopefully I will try my best to help you, okay, before you reach your final point. Okay. Otherwise, please make sure you subscribe this academic and normal YouTube channel. It will help you, and it will also help your future generation. Until next time, I wish you the best. Make sure you leave your comment in our comment box in case you have a challenge with a certain topic of high school or even in primary. Leave your comments down in the comment box, then I'll help you. Otherwise, have a nice day.